everybody. In this video, we're going to talk about how to multiply and divide mixed numbers and how you can help your students visualize this process. So let's start with multiplication, and I want to quickly review the idea of using the area of a rectangle to model multiplication. So if you're multiplying whole numbers, you can model this with the area of a rectangle by making a rectangle that's 3 units long and 2 units wide. And the area of the rectangle is 6 square units, which is one way you can visualize 3 times 2. If you have two fractions multiplied together, you can also model this with a rectangle. So let's say that I had a rectangle where the side lengths were 3/4 of a unit and 1/2 of a unit. Well, the area of that rectangle is a fraction of a square unit because the square unit is 1 unit by 1 unit. And you can see that that rectangle that I've drawn is taking up 3/8 of that square. And so this is the reason that 3/4 times 1/2 equals 3/8. And we can use this model to multiply mixed numbers. Because if I'm doing 1 2/3 times 2 4/5, the way that I can model this is by having a rectangle that's 2 units and 4/5 of a unit. So this distance right there on one side. And then 1 unit and 2/3 of a unit on the other side. So this black rectangle that I'm drawing here, the area of that will be the answer to this multiplication problem. Now, one of the misconceptions that students will sometimes have when they multiply mixed numbers is they'll just multiply the whole numbers together and multiply the fractions together. So they'll say something like 1 2/3 times 2 4/5 equals 2 8/15, which is not the correct answer, but we'll look at why that's true. So remembering that the area of this black rectangle should be equal to the product of 1 2/3 times 2 4/5, I'm going to look and see how I can find the area of this rectangle. And to do this, I'm going to extend these lines that are partitioning my side length into fifths so that they also partition the square units into fifths. So I'm just extending those. Then I'm also going to extend these so that this direction is split up into thirds. And then I'm going to find the area of my black rectangle. So the area of the black rectangle can be kind of broken up into 4 pieces. So I'm going to start off by finding the area of this. And the area of that is 2. And one way I can think about it is as 1 times 2, because this side length is 1, this side length is 2, and so 1 times 2 should give me that. Now, that piece is matching this part of the answer that is not correct. But let's keep going and see what the rest of the rectangle should be. So the area of this piece right here, this one is going to be 1 times 4/5. And this equals 4/5. And we can see that because this and this and this and this are each 1/5 of a whole square, because this whole square right here is cut up into 5 pieces. And so the area of that is 4/5 of a square unit. Then I can figure out the area of this part right here, and that one is a distance of 2/3 and 2 units across. So that's going to equal 4/3, and we can see that's true because each one of these little rectangles is 1/3 of a square unit, and we have 4 of them. And then this last piece right here, the area of that is going to be 2/3 times 4/5. And that gives us 8/15, which again also makes sense because this whole square is split up into 15 little rectangles, and our rectangle is covering 8 of them. Okay, so notice that the way that we calculated out the area of this rectangle, it does include a 2 and it does include an 8/15. However, it also includes this 4/5 and the 4/3. And this is the reason why you can't just multiply whole numbers and multiply fractions together when you're multiplying mixed numbers. This is also related to the idea of foiling that your students will learn about later when they get to algebra. Because essentially what we're doing here is we're multiplying 1 plus 2/3, because that's what 1 2/3 is. And we're multiplying 2 times 4/5. And this green part is doing 1 times 2. The yellow part is doing 1 times 4/5. The red part is doing 2/3 times 2. And the black part is doing 2/3 times 4/5. So you don't have to show your students that. This is just more for you as a teacher to know that this concept is related to foiling, which they'll learn about in algebra. So to find the area of this black rectangle that I'm trying to find the area of, I basically just need to combine the green with the yellow with the red with the black. And since the 4/5, 4/3, and 8/15 are all fractions, I'm going to find a common denominator of 15. So I'm going to do 4/3 times 5 in the numerator and denominator to get 20/15. And basically what I'm doing there is I'm taking each one of these thirds and splitting them up into fifths. So it would look kind of like that. And the number of 15ths that I have is 20 in that red space. Then in the yellow space, I'm going to multiply by 3 in the numerator and denominator, which gives me 12/15. And that's basically just splitting this up into thirds. And so I have 12 of those smaller rectangles, and there's 15 in the unit square altogether. And then the 8/15 is already 8/15. So now that all of those pieces are the same size and they're all 15ths, now I can combine them together. And 12/15 plus 8/15 is 20/15 plus the 20/15 in the red section gives me 40/15. And that number is 2 10/15, or you could also reduce the 10/15 to be 2/3. And then I also have to combine that together with this green 2. So when I take the green 2 and I combine it with the 2 and the 2/3, I get an answer of 4 2/3, which is very different than this incorrect answer of 2 8/15. Because again, the 2 and the 8/15 is only finding the area of this piece and this piece, but it's not finding the area of the whole rectangle. So I'm going to erase this part because that's not correct. And I'm going to show you another method that you can use to help your students find this answer without having to draw the whole rectangle out. I think it's valuable to show your students this area model to help them understand why they can't just multiply the whole numbers and the fractions, but especially when you have numbers with fractions with really big denominators or really big numbers, the process of actually drawing out the rectangle can be really clunky. So another way that you can find the product of two mixed numbers without having to draw the rectangles is to convert the two mixed numbers into improper fractions. So what that would look like is you would say 1 2/3 is equivalent to 5/3. And essentially what you're doing there is rather than having a unit of 1 2/3, you're splitting this unit up into thirds. So you just have 5/3 along that whole side length. And then we're going to multiply this by the improper fraction that's equivalent to 2 4/5, which is 14/5. And so essentially what that one's doing is it's splitting this up into fifths, like this. And so this whole distance along here is 14/5. And what that does is it makes it so that you can just find the area of the whole rectangle all at once without having to split it up into these 4 little smaller pieces. And so if you do 5 times 14, this equals 70. And 3 times 5 equals 15. And basically that's saying that all of these little boxes or little rectangles in this space, there's 70 of them. And the size of those in comparison to a unit square is that it takes 15 of them to make 1 unit square. Then from there you can reduce this fraction. So 70/15 can be reduced by 5. 70 divided by 5 is 14. 15 divided by 5 is 3. You could also get that reduced answer by reducing 5 divided by 5 before you multiply. That would also work. But you get 14/3, which if you convert that to a mixed number, that gives you 4 wholes and 2/3. And notice that that's the same fraction that we got with the other method using the rectangle. So when you're teaching your students to multiply mixed numbers, I would first show them an area model like we did here to show them why you can't multiply whole numbers and then multiply fractions because that's ignoring like the yellow and red part of the rectangle. So I would first show them that, and then I would show them an equivalent version of doing the improper fractions, so kind of what I did here in purple. And then you can move on to harder problems that are more difficult to draw in a rectangle form. You know, like 6 7/8 times 9 and, I don't know, 12/14 or something. Because those multiplication problems would be very difficult to model with a rectangle just because your rectangle would be so big. But that's kind of the order that I would recommend introducing the process of multiplying mixed numbers to your students with. So that's how you multiply mixed numbers. Let's talk about how you divide mixed numbers. So when we're dividing numbers, remember there's two different ways you can think about division. You can think about it as taking a certain amount and splitting it up into an equal number of groups and then figuring out how much is in each group. And this is usually a good model to use if you're dividing by a whole number. But if you're dividing by a fraction or a mixed number in this case, it's kind of hard to figure out like how to split it up into a fractional number of groups or a mixed number of groups. And so in that case, it's usually easier to think about it as measurement division, where you take an amount and you split it up into groups of a certain size, and you figure out how many groups you have. So this word problem would be a good example of how you could introduce this to your students. Because Ellie has 4 2/5 cups of flour, and it takes 1 3/5 cups to make a batch of muffins. And the question is how many batches can she make? So this word problem is modeling 4 2/5 divided by 1 3/5 because we're splitting 4 2/5 cups of flour into groups of 1 3/5. So 4 2/5 represents the amount of flour that we have. And if we look at the number of groups that we can make of 1 3/5, let's see what we get. So if I go 1 unit and 3/5 of a unit, that means that this part is 1 batch. So this gives me 1 batch of muffins. Now if I go another unit, so from 1 3/5 to 2 3/5, that's 1 whole unit because that's 5/5. Then I can also go another 3/5, and that makes a second batch. Now notice that this distance that's creating each batch is basically 8/5. So if I were to count this, I'd have 1, 2, 3, 4, 5, 6, 7, 8/5, which makes sense because 1 3/5, if you write it as an improper fraction, is 8/5. So that might be an easier way of counting this. So let's do our next batch like that. And we have 1, 2, 3, 4, 5, 6, 7, 8/5. And so that means that the third batch would need 4 4/5 cups of flour. However, we don't have that much flour because we only have 4 2/5. So what this means is that our answer is that we can make 2 full batches and we can make a fraction of a batch. So to make a whole batch, we would need 8/5, and we only have 6 of those. And so that means that the fraction of a batch that we can make is 6/8, which you could also reduce to be 2 3/4. So it looks like we can make 2 3/4 of a batch of muffins. Now the question is there an easier way to calculate this? Because this gives your students a really good conceptual understanding of what the division means. So you would definitely want to go through several word problems like this so they really understand what the division of mixed numbers looks like. And then you can move on to teaching them an algorithm that makes it easy to calculate without drawing it all out on a number line. So similar to multiplying mixed numbers, the way that algorithm works is you convert the mixed numbers into improper fractions. So 4 2/5 is the same thing as 22/5. And that makes sense because this point on the number line, if you were to count the little teeny tick marks, there would be 22 of them. Because each unit has 5/5. We have 4 whole units, so that's 20/5 plus these extra 2/5 right here. So you say, okay, I have 22/5, and I want to divide them into groups of 8/5, because again, 1 3/5 is equivalent to 8/5. And the number of groups that I can make, if I take 22/5 and I divide them into groups of 8/5, that means that I can have 22/8 over 5 divided by 5, which is 1. And 22/8, since 16/8 is the number 2, I would have 2 wholes. And then I would have 6 more 8s beyond that, because 22 minus 16 is 6. And that gives me the 2 6/8, which reduces to 2 3/4. So that's another way that you can teach your students how to calculate the division of mixed numbers once they understand the concept of what it actually means. So I hope that video was helpful. If you have any questions, let me know, and I hope you have a good day.